Today we're talking about part 10 of the gravel wheel design journey, and that is working with UNLV. So when we left Calgary, we knew that we needed a team to help us process the data and determine the protocol. Fortunately for us, there are two professors at UNLV in the kinesiology department who are excellent cyclists, and they were very excited to help us with the project. So we worked back and forth with UNLV and with Aerolab, and we defined a protocol that has allowed us to measure CRR and CDA simultaneously. So the test goes like this. The first thing you have to do is we found a course that had consistent pavement, and it is an 800 meter out and back, so 800 meters out and 800 meters back. And we vary the power on each leg, so we do 3 total legs. So the first out leg is 180 watts. The second out and back leg is 220 watts, and the third out and back leg is 260 watts. Now, the variance in power allows the algorithm to calculate the CRR and CDA simultaneously, and it's pretty cool when you see the results. The other thing you have to do is you have to take a number of other measurements to basically verify that you are getting the right numbers. So one of the first things we learned is that temperature has an effect, and so we needed to temperature compensate. And the way that we do that is we start with roller testing, and we do a number of pressures with a tire on a cold morning, and then we do a number of pressures again in the afternoon with a higher temperature. So that allows us on a roller to basically set a rolling resistance number, and we can then temperature compensate. The other things we do is we have a very special pressure gauge, which we've talked about earlier in this gravel design series. The truth, basically, we set our pressures for the front and rear tire very precisely. We record those numbers. We also record the tire width, so we measure the tire width with calipers, and we also have the tire size and everything else like that. The bike and rider weight is measured, and then we go out and we ride the course. Now, when you're riding the course, you have to be extremely still and very stationary, because if you move around a lot, you're changing your basically your frontal area and how the sensor picks up your CDA value. So you want to keep that as steady as possible. And so you go out and you do a number of runs. So we ran on the first test here, which is in the article below, 4 different pressures. We started at 65 psi. We then moved to 80 psi, 95 psi, and 110 psi. And we looked at 2 different tire sizes. The first one that you'll see in the article is a 25 millimeter Continental GP 5000, and the second one is a 32 millimeter Continental GP 5000. And the results are quite staggering. There's about a 10 to 20% difference in the CDA or CRR, the rolling resistance numbers, between those 2 tires, and meaning that the 32 millimeter tire produces a much lower rolling resistance at the same pressures. We will have a full detailed view of a number of different tire sizes, different pressures, different rims, and a number of things that will go into basically a table that allows people to select the best pressure for themselves and their weight, and we also take into consideration road surfaces. The other thing you'll notice in the graphs as you're taking a look at it, as we've talked about before, the impedance point, we were able to basically map that impedance point. Now, the impedance point happens somewhere between 95 and 110 psi. So what does that tell us? It tells us that we don't really want to get above 95 psi, but we want to get sort of close to that number. And again, this all depends on your surface, your road surface, because if it's rougher, then your impedance point's going to happen sooner. If it's smoother, it'll happen later. So yeah, it's proving that lower tire pressures are faster because we're keeping ourselves away from that impedance point. And again, we'll have more information on pressure selection and all of that in the future. But super exciting, the work that we've done with UNLV, we're very happy about it. And now that we had basically proven that we can design a wheel that lowers rolling resistance, what we had to determine was, are we able to design a gravel wheel that has an aerodynamic benefit? And that's why we went to CFD and scanning tires to get a really good understanding of what we could do from an aerodynamic perspective. And that'll be in part 11 next week, and we'll see you soon.